This is SpaceTime Series 27, Episode 129, for broadcast on the 25th of October 2024. Coming up on SpaceTime, the first evidence of a volcanic Splatocone on Mars, a distant exoplanet that may host a volcanic moon similar to Jupiter's Io, and a new study suggests the Sun may now be reaching the maximum period of space weather events, at least during the current solar cycle. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have detected what appears to be the first ever evidence of a volcanic Splatocone on the red planet Mars. One of the study's authors, Ian Flynn from the University of Idaho, says the cone appears to be similar to ones found here on Earth. Flynn identified the cone while studying an extinct Martian volcanic vent. He then undertook a detailed morphological investigation and ballistic modelling of the feature, and that supported his conclusion. Flynn says Splatocones are common on Earth, and it would be extremely unlikely that they didn't also exist on Mars. Now, since Splatocones can only form under the right conditions, their presence gives scientists a benchmark to shoot for when simulating Martian volcanoes. Splatocones are created by hot lumps of flying lava falling onto the surface during an explosive volcanic eruption, especially during sustained periods of lava fountaining. Flynn says they're found in many places on Earth, including Iceland and the craters of the Moon National Monument and Preserve in Idaho. However, until now, there's never been any solid evidence for their existence on the red planet. Flynn says the similarity between the Martian and Icelandic Splatocones indicates that the eruption dynamics occurring in Iceland also occur on Mars. He says it expands the range of volcanic eruption styles possible on the red planet. This discovery can provide clues about how volcanic eruptions happen on Mars, specifically regarding the gases in the magma and the environmental conditions at the time the eruption occurred. It's also further confirmation that Icelandic and Indionian volcanoes are erupting now in the same way volcanoes erupted millions of years ago on the red planet. Flynn says the discovery also fills a distinct observational gap in Martian volcanology, and it lays the groundwork for future investigations of Splatocone features on the red planet. Mars, of course, is also home to Olympus-mons. That's the largest volcano in our solar system. Olympus-mons is a gigantic shield volcano over 21.9 kilometres or 72,000 feet high. That's about 2.5 times the elevation of Mount Everest above sea level. It's associated with the Tharsis Montes volcanic region of Mars. Olympus-mons is the youngest of the large volcanoes on the red planet, having last erupted an estimated 25 million years ago. This is SpaceTime. Still to come, a distant exoplanet that may also host a volcanic moon just like Jupiter's Io, and a new study suggests the Sun may now be reaching the maximum period of space weather events, at least during the current solar cycle. All that and more still to come on SpaceTime. A new study has revealed possible signs of a rocky volcanic moon orbiting an exoplanet some 635 light-years away. An exoplanet is a planet orbiting a star other than the Sun. The biggest clue for this potential discovery is a sodium cloud that is close to but slightly out of sync with the exoplanet it's orbiting. That exoplanet's a Saturn-sized gas giant named WASP-49b. Within our solar system, gas emissions from Jupiter's volcanic moon Io create a very similar phenomenon. Although astronomers are yet to discover a so-called exomoon, that is a moon orbiting a planet outside our solar system, multiple candidates have been identified. It's likely that these planetary companions have gone undetected because they're too small and dim for current telescopes to detect. The sodium cloud around WASP-49b was first detected back in 2017, catching the attention of Afura Osa from Caltech. Osa has spent years investigating how exomoons could be detected by their volcanic activity. For example, Io, the most volcanic body in our solar system, is constantly spewing sulfur dioxide, sodium, potassium and other gases that can form vast clouds around Jupiter up to 1,000 times the gas giant's radius. It's possible that astronomers looking at other star systems could detect a similar gas cloud like Io's, even if the Moon itself is too small to see. Both WASP-49b and its host star are composed mostly of hydrogen and helium, with trace amounts of sodium. But neither contains enough sodium to account for this cloud, which appears to be coming from a source that's producing roughly 100,000 kilograms of sodium every second. Now, even if the star or planet could produce that much sodium, it's unclear what sort of mechanism could eject that into space. So Ozu and colleagues set out to try and determine if the likely source is a volcanic exomoon. Now, the work proved challenging because of the great distance to this system. Also, the star, planet and cloud often overlap, occupying the same tiny faraway point in space. That meant the authors had to watch the system for quite a long time. Their findings, reported in the astrophysical journal Letters, found several pieces of evidence suggesting that this cloud was created by a separate body orbiting the planet, although additional research will be needed to confirm the cloud's behaviour. For example, twice their observations indicated the cloud suddenly increased in size, as if it was being refueled when it wasn't next to the planet. They also observed the cloud moving faster than the planet in a way that would seem impossible unless it was being generated by another body moving independent of and faster than the planet. And Ozu thinks this is a really crucial piece of evidence. Also, the cloud appears to be moving in the opposite direction, which physics tells us it should be going if it were part of the planet's atmosphere. Now, while these observations have all intrigued the research team, they would still need to observe the system for far longer to be sure of the cloud's true orbit and structure. For part of their sleuthing, the authors used the European Southern Observatory's VLT, or Very Large Telescope, in Chile. They eventually established that the cloud's located high above the planet's atmosphere, much like the cloud of gas Io produces around Jupiter. And they also used computer models to illustrate the exomoon scenario and then compared that with the data they have. The exoplanet WASP-49b orbits its host star every 2.8 Earth days with clock-like regularity. But the cloud appeared and disappeared behind the star or behind the planet at seemingly irregular intervals. Now, using their model, the authors showed that a moon with about an 8-hour orbit around the planet could explain the cloud's motion and activity, including the way it sometimes seemed to move in front of the planet and didn't seem to be associated with a particular region of the planet. All in all, the evidence is really compelling that something other than the planet or the star are producing this cloud. We know Io's volcanoes are driven by Jupiter's gravity, which squeezes the moon as it gets closer to the planet, then reduces its grip as the moon moves away. This constant flexing in and out produces friction in the tiny moon's interior, leading to a process called gravitational tidal volcanism. If WASP-49b has a moon similar in size to the Earth's, Ozu and colleagues estimate that the rapid loss of mass combined with the squeezing from the planet's gravity would eventually cause this little moon to disintegrate. He says if there really is a moon there, it's destined to have a very destructive ending. This report from NASA TV.
A rocky, volcanic moon could be orbiting a planet more than 600 light-years from Earth. Exomoons, or moons around planets outside our solar system, are likely too small to see directly. But astronomers think volcanic exomoons could make themselves known by creating massive clouds of volcanic gas. A new study looked at a large sodium cloud discovered in 2017 near the exoplanet WASP-49b. Scientists found evidence that the cloud is not produced by the planet or the star it orbits. Instead, the motion of the cloud suggests it originated from another object, possibly a volcanic exomoon. To get to this conclusion, researchers used a telescope on Earth to observe the silhouettes of the cloud and the exoplanet as they passed in front of the star. In one observation, the researchers saw the sodium cloud moving faster than the planet and away from Earth. If the cloud was coming from the exoplanet, the scientists would expect it to move toward Earth. They think this means the cloud was coming from a different source, like an exomoon. Jupiter's moon Io also spews a volcanic cloud into space. It pumps sodium, sulfur, and other gases, creating a massive cloud 1,000 times wider than Jupiter. Io has volcanoes because Jupiter's gravity squeezes the moon's interior, heating it. Scientists think WASP-49b's gravitational squeezing is likely even more intense and may eventually cause its exomoon to disintegrate. While more observations are needed to confirm the existence of this exomoon, what researchers have found is promising.
This is SpaceTime. Still to come, scientists say the Sun could be reaching the maximum period of space weather events as it reaches solar max for solar cycle 25. And later in the science report, a new study has found the rise in human life expectancy is slowing down dramatically. All that and more still to come on SpaceTime. Representatives from NASA, the National Oceanographic and Atmospheric Administration, NOAA, together with the International Solar Cycle Prediction Panel, have announced that the Sun has now reached its solar maximum period, which could continue for the next year or so. The Sun's 11-year solar cycle is a natural geomagnetic cycle during which the Sun transitions between low and high magnetic activity. At the height of the solar cycle, known as solar maximum, or solar max for short, the Sun's magnetic poles will flip, reversing polarity, so the Sun's north pole becomes south and the Sun's south pole north. NASA and NOAA track sunspots to determine and predict the progress of the solar cycle and ultimately solar activity based on sunspots. Sunspots are cooler and consequently darker regions on the Sun's surface caused by a concentration of magnetic field lines breaking through the surface and extending out into space from deep below. Sunspots are the visible component of active regions, areas of intense and complex magnetic fields on the Sun that are the source of solar flares and coronal mass ejections. Solar flares are blasts of energy out from the surface caused when magnetic field lines snap. If these explosions are powerful enough, they can fling solar material and magnetic field out into space with them. That's a coronal mass ejection. During solar maximum, the number of sunspots and therefore the amount of solar activity increases. NASA's Director of Space Weather, Jamie Favors, says the increase in activity provides an exciting opportunity to learn more about our nearest star. But it also causes real effects on Earth and throughout our solar system. The solar activity strongly influences conditions in space known as space weather. This can affect satellites and astronauts, as well as communications and navigation systems, and even power grids on the ground. When the Sun is most active, space weather events become more frequent and more violent. And we've seen that in recent months, with solar activity leading to increased auroral visibility, as well as impacts on satellites and infrastructure. During May, a barrage of large solar flares and coronal mass ejections launched clouds of charged particles and magnetic fields towards the Earth. That created the strongest geomagnetic storm in 2 decades, and possibly among the strongest displays of auroral activity on record in the last 500 years. And of course, another strong solar event hit the Earth earlier this month, an X9.1 class solar flare on October the 3rd. It was the most powerful blast in the current solar cycle so far. An X-class denotes the most intense solar flares, while the number provides more information about its strength. Scientists anticipate that the maximum phase of the current solar cycle will last probably another year or so, and then the Sun will enter its declining phase, which will lead back to the next solar minimum. The current cycle, classified as solar cycle 25, began solar minimum in late 2019. That means we shouldn't expect the next solar minimum until 2030. Solar cycles have been tracked by astronomers since Galileo first observed sunspots in the 1600s. But they're not all the same. Each solar cycle is just a little bit different. Some peak for longer periods, others for shorter amounts of time, and others have smaller peaks that last longer. The last solar cycle was considered fairly mild, but the current solar cycle is showing far higher levels of sunspot activity. NOAA anticipates additional solar and geomagnetic storms during the current solar maximum period, and that will lead to opportunities to spot more auroral activity over the next few months, as well as the potential for technology impacts. Interestingly, though less frequent, scientists often see a significant level of storm activity during the declining phase of the solar cycle. That'll be something they'll be looking out for this time round as well. Of course, one of the big advantages now compared to the last solar cycle is NASA's Parker Solar Probe mission, which is exploring the Sun and its activity. In December, Parker will make its closest ever approach to the Sun's surface. In fact, the spacecraft will swoop down to just 6.1 million kilometres above the visible surface of the Sun. That'll be the closest any man-made object has been to the Sun. And it doesn't end there. Because of the Sun's immense gravity, the spacecraft will be moving at over 692,000 kilometres an hour. That'll make the Parker Solar Probe the fastest man-made object ever flown. The December flyby will be the first of 3 planned close approaches by Parker at this distance, and that will help scientists better understand solar weather at its source. NASA's also launching several other missions over the next year or so that will further help scientists better understand space weather as it impacts across the solar system. These are important because space weather predictions are critical for supporting spacecraft and astronauts, including NASA's Artemis campaign. Remember, Artemis astronauts will be flying to the Moon. That's well beyond the protective shield offered by Earth's magnetosphere. So surveying the space environment will be a vital part of understanding and mitigating astronauts' exposure to space radiation. This report from NASA TV.
Roughly every 11 years, the Sun's magnetic field completely flips. This means the Sun's north and south magnetic poles switch places. Around the time of this flip, solar activity gradually ramps up. The Sun will have more sunspots and solar eruptions like solar flares and coronal mass ejections. The peak of this activity is known as solar maximum. Solar maximum marks the halfway point of the solar cycle and usually means a year or two of high solar activity. During this time, we might see more severe geomagnetic storms at Earth, which trigger aurora, but also threaten our communications, satellites, and power grids. NASA scientists continue to study the solar cycle so we can better understand solar activity to protect our technology in space and on Earth.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has found that the rise in human life expectancy is slowing down. A report in the journal Nature analysed data from 10 high-income nations, including Australia and 7 other countries with the longest-lived populations. They found that the rate of increase has slowed down since the 20th century. The authors conclude that unless biological aging can be markedly slowed, survival to the age of 100 is unlikely to ever exceed 15% for females and just 5% for males. They believe that humanity's battle for long life may well have largely been accomplished, and they describe this as a celebration of advances in public health and medicine that saw life expectancy increase by around 30 years during the 20th century. A new study has found that even low-risk alcohol drinking causes higher mortality in adults over the age of 60 with health-related or socioeconomic risk factors. A report in the Journal of the American Medical Association looked at over 135,000 UK adults over the age of 60 described as occasional to high-risk drinkers based on their daily alcohol intake. They also examined possible links between deaths, drinking, and health or socioeconomic risks. They found that moderate to high-risk drinking was associated with more deaths overall, but low or moderate-risk drinking was also linked to increased death rates, especially cancer deaths, in adults scoring higher for frailty or deprivation. Interestingly, this increase did not affect those who preferred wine or drank only with meals. However, the authors caution that this still requires further investigation. A new study warns that thawing permafrost may be accelerating Arctic riverbank erosion. A report in the journal Nature analysed the Koyukuk River in Alaska using a novel computational method that allowed the researchers to study the river in a finer resolution than possible with traditional satellite imagery. They found that permafrost reduced erosion in the riverbanks by 47% compared to scenarios in which no permafrost was present. They also showed that permafrost thaw may lead to a 30 to 100% increase in river migration rates across the Arctic. However, they say it's still uncertain how mechanisms such as increased vegetation in the wake of thawing permafrost may or may not strengthen riverbanks from erosion. Well, one of the biggest topics on the Australian political agenda at the moment is the Labor government's Misinformation-Disinformation Internet Censor Bill. If passed, this legislation would allow the government to determine what qualifies as truth and what must be blocked for the public good. Now, importantly, this same legislation would exempt politicians and selected journalists from these laws. So, the real question for Australians is, can politicians and bureaucrats be trusted? Or is this more likely to result in a sort of Orwellian Ministry of Truth? After all, these are the same politicians and faceless bureaucrats on both sides of the aisle responsible for the Medicare scare campaign, claims that you're likely to get COVID from pizza boxes, arresting a pregnant woman for promoting an anti-lockdown rally while at the same time supporting BLM marches, forcing social media companies to censor and pull down thousands of posts criticising government, including humorous memes. Then there are the classics, like promotion of the Russia collusion hoax and false claims that the Hunter Biden laptop was disinformation when in fact it was real, and of course the list goes on. Those opposing the new legislation say people should basically be able to say what they want, as long as it doesn't cause harm or encourage and promote violence. And they should be treated as publishers, responsible for everything they say and write under existing laws of libel, slander and defamation, such as real publishers. Tim Mendham says while Australian skeptics don't have a position on the legislation itself, their views on the freedom of speech are clear.
It's obviously a pretty important issue. I mean, it's something that people raise all the time as their freedom of speech. It's a vexed issue, and people keep referring to earlier references and things, some to the Universal Declaration of Human Rights, some to the US Constitution, which is strange in Australia because it doesn't apply, some to the Magna Carta, etc. What we're talking about here is people's right to state their point of view. And there is generally agreed that you do have the right to state your point of view. Some people, regardless of how obnoxious your point of view is. But then the other issue is about lying, misinformation and disinformation. Misinformation is things that are wrong. Disinformation is consciously stating things that are wrong. So you're disinforming people. And this often happens with people who are making claims, say, about the anti-vax movement. They will make lots of claims that they will say are true that are lies. I won't even say mistakes. Let's call them lies. And the question then is, should you have freedom of speech to say lies? And most people would say no. It's fine to express your opinion. I don't like you, blah, blah, blah. But you can't say, I don't like you because you do this or because you are this sort of person, which may be a lie. So as soon as you say you have to stop saying that, you are impinging on their freedom of speech. And the thing to keep in mind is that the skeptics need to keep it in mind as well. There is no such thing as an absolute freedom of speech. It's a thing which is said and applied. It is a nice idea, and that's the way it is in the Universal Declaration of Human Rights. It came out after the Second World War. It's a set of agreements that these principles should apply, and people say, yep, they should apply, but they're not legally binding, and that's what a lot of people don't understand. You may take elements of that and write them into your law, and then it does become legally binding, but the Declaration of Human Rights is not a legally binding document. What is a legally binding document when you agree to it is the International Covenant on Civil and Political Rights, which basically takes the Universal Declaration of Human Rights and makes it into a law, done by the UN, same as the Declaration. So the Covenant is a different thing. It's a lot more legal. If you accept the Covenant, you accept these things as law. And the interesting thing is that the ICCPR, the Covenant, says specifically regarding, I think it's Article 19 or something of the Declaration, that freedom of speech, even though it's a great idea, may be subject to certain restrictions. And these restrictions are for the respect of the rights or reputations of others, which is that I can't lie about you, and the protection of national security or public order. The old story, you can't yell fire in a crowded theatre. And even the US Supreme Court says that First Amendment of the US Constitution, which does say freedom of speech, that is not free everywhere. So the whole issue is that there is no such thing as absolute freedom of speech. The classic case is John Stuart Mill, the writer who was writing in, the 1700s, I think he was, had a book called On Liberty, and he raises the issue of the harm principle. Yes, freedom of speech is important. You should have the right to freedom of speech, except when it causes harm. So that's basically what the skeptic's point of view is. Yes, you can say you disagree with vaccination, fine. You can say, I believe in the Loch Ness Monster, fine. But when you start lying about it, and especially when those lies cause harm, like when you say the measles, mumps, and rubella vaccination causes autism when it doesn't, and that causes harm to people because it scares them off vaccination and that sort of stuff, it's wrong and you can't say it.
This all relates to the internet and social media. What about simply forcing social media to accept the same rules as the rest of society? Say, me as a publisher of information, if I say something that's untrue, I can be sued for that. If I defame somebody, I can be sued for that. Shouldn't the same then apply to social media, that if you say something on social media if you defame someone, then you should be sued for that?
Yes, I would agree. I mean, the whole trouble was that social media has developed so quickly and that the law is so slow to respond that it probably hasn't caught up. But yeah, I mean, you're publishing things wherever they're published, in print, TV, radio or online, the same rules should apply. The question is that if someone says something on your website, are you as the website owner responsible for what they say?
Or are you just a carriage service like Telstra?
That's right. Are you just a carriage service? But then the carriage service should have an obligation to moderate. Now, that's hard to do, right, to moderate everything that's said on your website as comments or whatever, but maybe that's the thing you have to do.
Well, that's what it comes down to, isn't it? Is social media like a postal service or a telecommunications company, or is it a publisher like CBS or ABC or what have you?
That's the question, and that's a legal question, and certainly probably the skeptics on principle would suggest that everywhere where someone is making statements and telling lies, regardless of where it is, they should be called up about it.
That's Tim Mindham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.